This video, I want to show my expectations on what I want you to know for sine, cosine, tangent, and cotangent as far as their graphs. So I remember when I was a student, just to memorize the basic shapes of the graph of the sine function, I find myself just on a blank sheet of paper, drawing an x and y axis, drawing the following shape, and then labeling the x-axis. In this case, because it's the sine function, it takes the sine function 2 pi radians to go through one of its cycles. The cycle of a trig function is called a period. So the period of the sine function is from 0 to 2 pi, meaning that after 2 pi radians, it continues to do the same exact thing over and over and over. It goes up and then down, comes back up, and it just keeps doing that forever to the right and forever to the left. If you wanted to, you could label further. Since this is 0 and that's 2 pi, halfway would be pi, and then halfway between 0 and pi would be pi over 2, and then halfway between 1 pi and 2 pi would be 1.5 pi or 3 pi over 2. You could do the same thing with cosine after you get good at memorizing that shape. Do the same exact thing because the period for the cosine is also 2 pi units, except you would be over and over practicing on a blank sheet of paper. Again, draw an x and y axis, and instead of starting at the origin and drawing this shape, start up at 0, 1 and go down and back up like this and draw that on a blank sheet of paper several times until you've memorized the shape of the sine and the cosine. What I forgot to mention about the sine function is that its low point is a y value of -1 and a high point of 1, and that's also true for the cosine function. It goes as low as -1 and +1. In later chapters we're going to change this, but good old cosine and sine without any transformations or shifts or stretches has a min of -1 and a max of 1. You could proceed to label the middle here pi if you wanted to, and then I guess because halfway between 0 and 2 pi is pi, you could label this pi over 2, and then halfway again between pi and 2 pi would be 1.5 pi or 3 pi over 2. Now this becomes important and useful when you're graphing tangent and cotangent. So let me switch over to a different screen here. Here is again the sine and cosine function. I'm going to use it to graph the tangent function and the cotangent function. Now it turns out the way we graph a period of the tangent and the cotangent function, you need to see a little bit different pieces of the sine and cosine. So for example, a minute ago, I had you plotting the cosine function, and hopefully you may have paused the video and got good at this, but I said to graph the cosine function, just draw this shape over and over and over until you get good at it. And then this would be, I'm terrible at drawing on the computer with a mouse, but you get the idea. This shape right here would be the shape I had you memorize for from 0 to 2 pi. So this right here would be 2 pi radians, remember? So it takes 2 pi radians for it to do a cycle, and then it continues on to the right forever and to the left forever doing that. So anyway, the reason I do this is to show you to graph one period of the tangent function. Turns out one period of the tangent function would be from -pi over 2 to pi over 2, and to see what's happening in the tangent function, it's important for you to realize that the tangent function, if you don't know it already, is defined to be the sine of x over the cosine of x. So I can use the values of sine x and cosine x to help me graph the tangent of x. Now I'm not going to get into too many details in this video, but just to point out that in a previous lesson you were asked to find the domain of the tangent and cotangent in terms of where it's undefined, and this is just a better way of explaining where the tangent and cotangent function would be undefined. It's just easy to remember if you know the graphs of sine and cosine. So for example, the tangent function, because I can define it as sine over cosine, it would be undefined where the cosine is 0. Well, that's easy to remember where the cosine is 0 now if you memorize this graph. The cosine is 0. The cosine is 0 at -pi over 2 and at pi over 2. So if the cosine of x outputs 0 here at -pi over 2 and at pi over 2, then you're going to have a 0 in the denominator of this fraction, meaning the tangent function is going to be undefined. There's not going to be a y value there. Turns out that near that, when your denominator gets close to 0, your function values skyrocket. So this creates a vertical asymptote. So I'm going to draw some dotted lines here from -pi over 2 to pi over 2. Your graphing calculator wouldn't do this, but as a human, it's very easy to just draw a couple vertical lines here. and these would be the vertical lines x equals negative pi over 2 and x equals pi over 2. And what's going to happen is, as the cosine x gets closer to 0, it's very close to 0, your denominator, this fraction, gets close to 0, and whenever you divide by a really small number, something close to 0, then the fraction itself, which would be the y values of my tangent function, are going to get very, very large. So what happens here is that the tangent function basically skyrockets and approaches that asymptote here at pi over 2, and then goes down to negative infinity at negative pi over 2. So hopefully you learned about asymptotes in college algebra. Now you're just to memorize wherever the cosine is 0, that's where you get your vertical asymptotes of the tangent function. So this would be one period of the tangent, and this would continue on forever. So for example, that to the right of this, the tangent function would just keep doing this forever and ever and ever, and to the left as well. So in a minute, maybe we'll go to our graphing calculator and show you that it does this. Now, over here to the cotangent function, I can make the same argument, except cotangent, instead of it being sine over cosine like the tangent is, it's cosine over sine. So it's going to have its vertical asymptotes, or it's going to be undefined, for all x values for which sine x is 0. And earlier in the video I had you memorize that the sine function looks like this, and it takes 2 pi radians for it to complete its cycle. So a few minutes ago we graphed this portion of the sine function, and again I recommend that you at some point take a blank sheet of paper and memorize that shape and realize the sine function just keeps doing that forever to the right and forever to the left. So it turns out that the two key points on cotangent function are again where the sine is 0, and the sine function is 0 here at x equals 0, and again at, that would be x equals pi. So if this is 0 here and this is 2 pi here, then halfway right here would be pi. So we are going to have vertical asymptotes in the cotangent function wherever the sine of x is equal to 0. So the sine function, clearly from this picture, I'll put 0 at 0. So you're going to have a vertical asymptote at x equals 0. And by this graph, you can see that the output, the y value of the sine function, is 0 again here at pi radians. So over here at pi, you're going to have another vertical asymptote. So it turns out the period for cotangent is the same as tangent function. Takes pi over 2, or excuse me, pi units to duplicate itself. So from negative pi over 2 to pi over 2, that's pi units, and it takes pi units, or pi radians, for tangent to keep repeating itself. So the cotangent function has that same period here from 0 to pi, so it has a period of pi, and every pi radians it's going to just keep duplicating itself. Unlike the tangent function though, the cotangent, rather than having this shape, it's sort of the upside down version of that. It goes like this and approaches its vertical asymptotes like that. And I realize this is not a pretty video, but I think hopefully some of the concepts in this video made sense. And then because the period's pi units, then over at 2 pi, which would be pi more units to the right of pi, this behavior is going to repeat itself. You're going to have another vertical asymptote, and again it's just going to keep doing that forever and ever and ever. So if you wanted to verify this on the graphing calculator, you could go to your graphing calculator, and I already have sine x over cosine x typed in. That would be the definition of the tangent function. So to see one of its cycles, or one of its period, I would put my window at negative pi over 2 to pi over 2. And that's exactly what I did. If I go to window, this is negative pi over 2 to pi over 2. I typed it in using the pi key right here on the calculator. And because the tangent function goes infinitely high and infinitely low, having my y min and y max of negative 1 to 1 doesn't make so much sense. So I'm going to take a stab in the dark here and change that to negative 10, excuse me, negative 10, and down arrow, and change my y max to 10. And notice that if I press mode, I am indeed in radian mode. All of these graphs that I've shown you were done in, I was thinking in radians. So there's one cycle of the tangent function. You're seeing the graphing calculator's version of this. where it starts down here and goes up forever. And if I was to change my window from negative pi over 2 to pi over 2, if I would extend that into pi units, which would be 3 pi over 2, so that would be over here, that would be 3 pi over 2 right here, then I would see another cycle of the tangent function. So here's my first cycle, just to show you that it repeats every pi radians. There would be another cycle, and this goes on forever. You could do a very similar thing to graph the cotangent. So that was really fast. I hope you can rewind the video and start from the beginning and take my recommendation of just getting the practice of starting with an x and y axis on a blank sheet of paper. And I know this isn't pretty, but just practicing starting at the origin and graphing one cycle of the sine, labeling it 0 to 2 pi to remind yourself the period is 2 pi radians. And then when you get good at that, do the same, start with an x and y axis, except draw this picture and label it from 0 to 2 pi. Know that that's the cosine function, and that they go as low as -1 and as high as +1 on both of these. So very quick video, a lot of concepts to learn in one video. Not expecting to be masters at this just after watching it, but that's just an intro to what you should know, and hopefully that helps you throughout the class.